Okay, next we move on to prehension. So I just did prehension, which is reaching and grasping object. So the actions involving both components, well, reaching for and grasping of an object is called prehension. And Generod in 1984 proposed that there are two components in prehension, which is transport and grasping component. And this was by the analysis that Generod did, and he concluded that those two components are relatively independent. I'll just show you the graph. In the prehension task, like when I was reach for and grasping this block of wood, the typical graph will be the hand position will be close to the target, and the hand velocity will show two phases. One is the first phase of movement, and which is peak velocity, has peak velocity, and the second phase is slower velocity phase. So in those, at those moments, the velocity becomes a bit slower. And there is also the grip components, grasping components. So if we look at the grip size, which is the width between my index and the thumb, the grip aperture change would show like this pattern as close to the target. So there will be max grip aperture around this point of time. And what he found was the max grip aperture occurs about 75% of the total movement time. So this graph, the max aperture is about 1/3, 2/3, or about 75% of the total time. And interestingly, if you look at the slower component, slower velocity component, this happens about the same as the max aperture time. So this beginning of the slower component is about 2/3 or 75% of the total time. So in other words, if I start at this point and reaching for the wooden block, my max aperture will happen at 75% of the total time. And at the 75% of max aperture, the slow velocity component will begin. So Generod first proposed that it is two different components, transport and grasp components, because mainly, well, for transporting we might use the vision for action, and for grasping components we might use vision for perception. So he thought the transport and grasping component, well, even though it's timely coupled, 75% of moving time, the grip aperture, max grip aperture happen, and also at the same time the slower phase of the transport of the hand also happen at 75%. So there was time coupling between the two components, but for the spatial components he thought it was totally different, two different components. So we know that there is temporal coupling between two components. But Jacobson and Goodale also found that there is spatial component between two. So let's say what he did was they changed the object size and distance and recorded the hand and grip aperture movement. And what he found out was, let's say, so there's two different object size and distance, or distance, different distance. Maybe this is. So if I start from my face and reach for that further away wooden block, which has smaller size, and well, the closer one with the bigger size wooden block, when the object size increased, the transfer velocity also increased. And for the distance, when the distance increased, that also affected the max grip aperture size. So max grip size also increased with the distance. So even though the size is particularly related to the grip aperture and the distance is related to transport time, transport velocity, those two were interrelated. So Jacobson and Goodale thought those two components were actually coordinated by higher order system. Spatially coordinated by a higher order system. Gentilucci et al. In 1992 did a novel task. So let's say I start here and reach for this object, and suddenly when I started moving, the object switched to the second one, so the distance increased as I start to move. So there were unexpected perturbation happening while at the beginning of the movement. So when the object was perturbed during the transfer phase, they found it out that both components, transport and grasping components, were affected. And the mechanisms was mainly transport components. The time to reach the object was affecting the grasping components. And in particular, the transport time was used for the initiation of hand closure time. So those two studies and other studies shows that not only the temporal coupling is happening between transport and grasping components, but also the spatial coupling is happening, which indicates the hierarchical control of the prehension. Now we move on to the role of vision in prehension. And